All right, let me collect those back up. Take a look at these answers, and if you didn't get anything, make sure you check something. Hey, Mr. Laverick said this was a pretty stacked class. He wasn't lying. We had 6 100s. Over there, we used this the top 5, and highest average of the 4 classes was here, which was a 90.3. Okay, so we had the highest average. So it looks like it's going to be a tough top 5 to get on.
Yeah. But you're drawing. Oh, -7. All right. Yes.
So you looked at the answer and figured it out.
I just looked at the board. The bottom half of
I couldn't even read the picture in the textbook.
I like prove that when I was like, I'm not letting that prove. Geometry is past me.
What is geometry?
Okay, on 61, let me just kind of go through this. You're asked to show this. You cannot assume it's true. That's probably the biggest thing when you start to do problems like that is you say, all right, if this is true, you can't use that. You have to use other facts to show it is true. And here's the hard part of this. If you don't have a ton of experience, you'll have a little bit more as we move through the year. But you can draw in lines. And the easiest thing to do there for this one is to draw in this diagonal along the base. Okay, draw on that diagonal. And I'm going to have to label it something different. So I'm going to label it. I use A, B, and C. I'm going to label it D. Well, this is like a rectangular or a square base, right? So this right angle here has to be a right angle. What can you tell me about A, B, and D? What relationship has to be true?
A squared plus B squared equals D squared.
Okay, A squared plus B squared has to equal D squared. Okay, that has to be true. Because you got a right angle there. Pythagorean theorem always works. All right, now what about D, C, and H? What about D, C, and H? Do they form a right triangle? Yes. So what fact can I use, Tyler?
D squared plus C squared equals H squared.
D squared plus C squared. Whoops, that's an H right there. No, it doesn't look like it. All right, we got all the information we need right there. Why can I now state that final statement? Okay. Why am I done? Well, look at your top statement. It says A squared plus B squared is the same as what? So I can take the D squared out and put in what? So that's replaced with A squared plus B squared plus C squared has to equal what? H squared. There you go. Okay. So use things we already know. It's already been accepted. to show something new. And so we'll do some of this. We're not going to have like geometry proofs where, where we prove two triangles congruent, but we prove, we'll prove different things congruent. And really, we kind of take, I think, more of a step in that direction than in Algebra 2 honors in terms of being able to show some things, not just being able to solve or use them, but be able to show why they're true. All right, double check your answers. 2, -8 there for 46. 48 is 0.47. All right, anything we need to go over up front on your end?
46.
All right, 46. What's the original? Can you help me out a little bit? What conditions do they give us? Oh, Maggie's got her book right here. What page are we on?
91.
91. And let's see here. 46. Find y such that the point 2y is 13 units from -10, -3. So 2y is 13 units away from. So we want this distance. Not that you have to draw it out, but -10, -3 would be over here somewhere. 2y would be here, and I want to find a point on here where that distance is 13. And what is this? -10, -3. Okay, distance formula. x2 minus x1 squared plus y2 minus y1 squared. So distance equals the square root. Okay, distance we know is 13. And now just treat these as your 2 points. I'm going to do negative. Let me go in this order. It depends on what order. I want to do 2 minus -10, which is 2 plus 10, right? Plus y minus -3. That's y plus 3 squared. All right, when you square both sides, square 13, 169. You get rid of the radical. That's 12 squared, which is 144. And then plus y plus 3 squared. All right, now you can FOIL that. That's what I did the other day. And that's fine. But also there's probably a little bit, I don't know, this might be a slight bit quicker. What happens if I subtract 144? What does that give me over here? 25. And really, what can I do right here? I can take the what? I can take square root if I want to. So it gives you plus or minus square root of, well, square root of 25 is 5 equals y plus 3. If you do that, and then that gives me y equals, I got to move that over there. And -3 plus 5 is 2. And then we get -8. So that's where my y coordinates would be. It would be 2, 2, and then 2, -8 for the two answers. So 2, 2, and 2, -8. Okay. Now, if you FOIL that out, that's absolutely fine. Factor it, no big deal. But just, if you notice that, I just want to show you too.
Could you show the setup of the equation for number 48?
48.
Yeah.
You got anything set up?
Just curious. Yeah, checker.
In your paper? So what do you got?
I have the square root of y minus x squared plus -4 minus 0 squared equals the square root of 8 minus x squared plus 3 minus 0 squared.
Oh, you lost me. It's all right. Let me see here. It's on the y-axis, right?
Yeah.
Did you say y minus x squared?
I don't. Yeah, that's
All right, so there's something there. Okay, this one here, 48. 7, negative 4. And what's the other one? 8, 3. And where is the point at? It is on the y-axis. Oh, I'm guessing. And it's going to be 0y. You need to use those. You need to use 0 for the x. Okay, you need to use 0 for the x. And so you're going to use the distance formula twice. Whoops. Set them equal to each other. So if I do that, I'm going to do 8 minus, well, let me do 0 minus 8 squared. Plus y minus 3 squared. So you should not have an x variable in this one. And then this one over here is going to be 0 minus 7 squared plus y minus negative 4, y plus 4, and then kind of go from there. Okay. All right, what I want to do is finish up section 2.2. You started it, well, you finished 2.1, you started 2.2, and I want to finish that up today, if we can. Well, we can. A lot of graphing, interpreting graphs in this chapter. We talked about yesterday in the video, you can plot points. But just doing -2, -1, 0, 1, and 2, that's not going to be sufficient to really get a picture most of the time. So you can plot more points, but we want to find key points. Intercepts are always key points. So we let x equal 0, find the y-intercept, let y equal 0, find the x-intercept. All right, we're going to talk about symmetries as well. All right. Symmetric with respect to the y-axis. Everybody got the notes? Everybody good on that from yesterday? Okay. Now that is just an example of a graph that is symmetric about the y-axis. Basically folded along the y-axis, it matches up. Algebraically, here's what the conditions are. So if xy is on the graph, then that means negative xy is on the graph. So the y-axis is what it's symmetric to, but the x's are the opposite. Okay, one's positive, one's negative. So that's always got to be the case in terms of algebra. All right, if it's symmetric to the x-axis, okay, then if xy is on the graph, x negative y is on the graph. So here's xy. Here is x negative y. And these two are a little bit easier to kind of use your, visualize, because you can just fold it across. Symmetric about the origin is not quite as easy because you don't have a line that you're folding it across. It's a point. But here's the condition. If xy is on the graph, okay, and let me use this point right here. If that is on the graph, well, let me use the positive one, which would be 2, 2, then negative x, negative y is on the graph. All right, here's how you kind of go about this. If you take one point, you draw through the origin, and if it's symmetric about the origin, then on that opposite side, it'll be the mirror point. Okay, so you can do that with any point. So if I, right here, through there, on that opposite side, that should be the mirror point, the negative x, negative y. So it's not a line we're folding across. We're drawing through the origin. All right, if you have the graph in front of you, heck of a lot easier, but you're going to have to be given an equation, and without graphing it, test it for its symmetry. Now the graph on the right, I know it's not on your paper, this is just so you have a visual of what y-axis symmetry is. It is not that graph. But how do we test that for symmetry algebraically? Okay, so here's what we do, is you take your equation, x squared equals y cubed, and you replace x with negative x, and you simplify it. And if you can simplify it to the original equation, then it is symmetric. If it cannot be simplified to the original equation, it's not symmetric. So if I take this x out and put in negative x, okay, well, what's quantity negative x squared? That is x squared, right? So do I get back the same thing? Yeah. So here's what's happening. So if I plug in a 2 versus a negative 2, I'm going to get the same answer back. So therefore, it is symmetric to the y-axis. So this one is. So it is symmetric to the y-axis. Okay. So plug in negative value, see if you can get the same thing. All right. So for the second part, symmetry with the x-axis. Okay, there's just a visual. Same equation. X squared equals y cubed. All right, take the y out, plug in negative y. So if we flip the y, we put in a negative versus a positive, do we get a different answer? And all you have to do is test to see whether it will come back to the original equation. Well, that's going to be x squared equals negative y to the third. Well, what's negative y cubed simplified to? Negative, it's going to have a negative. So can I get it back to the original? No. So this is not symmetric to the x-axis. So not symmetric to the x-axis. All right, now how about origin? Symmetry about the origin. Take the negative x out, or take the x out, put in negative x. Take the y out, put in negative y. So looking at that one, again, same equation, x squared equals y cubed. Negative x quantity squared equals negative y quantity cubed. And I end up with x squared equals negative y cubed. So it doesn't match, not symmetric about the origin. Not symmetric. About the origin. Okay. Now, you tested all three. That's not always the case. Let's just take one. We're just testing one thing. We're taking this different equation, and we're just testing it about the origin. So take the x out, put in negative x. Take the y out, and put in negative y. So negative x, I want to put in for x. Negative y, I want to put in for y. All right, that gives me a negative y equals 4 negative x cubed minus 5 times negative x. All right, simplify it where you can. And the negative y is negative y. And then that will end up, negative x cubed will give me negative 4x to the third. And then what about negative 5 times negative x? Treat it as a negative times negative, which gives me positive 5x. Okay, now compare. Now the question is, not does it look exactly like the original one, but can you convert it to the original one? So is this one symmetric? So if you make a quick glance, you might say no, because I got a negative y and that's a y. But why is this symmetric? It is because
You can negate everything.
yes, you can divide everything by -1. You can negate everything, and you can make it back, take it back to the original. So if I do divide everything by -1, and then I end up with y equals 4x cubed minus 5x. And so yes, it is symmetric about the origin. If I just go backwards to that last one, with like you can still negate here, but if I negate here, then I'm gonna make this a negative and I'll make that one a positive. You can never get it to match up exactly. One will always be off of the other. So just be careful. Don't just stop and say, all right, it doesn't match up exactly, therefore it's not symmetric. See if you can convert it to that. All right, we're going to talk about circles. This isn't on your paper just yet, but we should know how to calculate the distance between HK and XY. So HK is my center, XY is just a point on the circle, right? Well, distance formula, distance equals the square root. If I take x2 minus x1, it's x minus h squared plus, what will go in the other one, it would be y minus k. So I got plus y minus k squared. All right, well, the distance in the circle is the same as the what? Radius. So I'm going to take the d out and put in an r. So the radius equals the square root of x minus h squared plus y minus k squared. All right, how do I get rid of the square root? Do what to both sides? Square. So I'm going to square it. So I get r squared equals x minus h squared plus y minus k squared. All right, right there, that is the center radius form of the equation of a circle, which goes on that top line there. Oh, we're on the next page, sorry. So see where it says center radius form of the equation of a circle? That's it, right there. And where does it come from? Distance formula. You take any point on the circle and the center, which is HK, and then we're basically using the distance formula. Okay, so now we kind of establish where it comes from. Now the radius is always the square root of that. All right, find the center radius form of the circle with center -2, 4, and radius 3. So basically we want to substitute in that, and all we're doing is, hold on here. Here's your general form. Plug in for H, plug in for K, plug in for R. That's all we're doing. So now x minus -2 will become x plus 2. You got to do that. Okay, treat it as minus a negative. Plus y minus 4 squared, and 3 squared is 9. Okay, 3 squared is 9. All right, I want to make sure you at least know what the graph of this looks like or how to graph that. Okay, so what would that look like? The center is right there. And then I don't need every point. I just need 4 key points. The radius is what? 3. Go 3 left, go 3 right, go 3 up, go 3 down. So from this point, I go 1, 2, 3. I go, well, I'm just kind of guessing here. 1, 2, 3, 1, 2, 3, and then 1, 2, 3. And then there's your circle for that one. So once you know the center, just go 3 up, 3 down, 3 right, 3 left. Okay, so at least be able to recognize the graph or graph it. All right, go in the opposite direction. I give you the equation. Tell me what the center is. Tell me what the radius is. Center would be +5, -8. Okay, it's going to be the opposite of that sign. +5, -8. Radius is going to be the square root of 50. Don't cut it in half. That's probably the biggest. People just cut it in half. No, square root. Square root of 50. Now reduce that when it can. And that's 5 square root of 2. 5 square root of 2. Okay. All right, so you have this case here. All right, pretty straightforward. Boom, just pull the points out. Unfortunately, they're not all that way. Because what's the center radius of this thing? Well, does it look like the equation we just had? No, if it did, it would be easy. Now, what we gotta do, we gotta make it look like this. We gotta do that. How do we do that? We're gonna complete the square. Gotta do it. Okay, that's another reason completing the square comes into play. All right, here's the steps you wanna do. Take your x's, and we're gonna put those together. Leave a space. Plus y squared plus 10y. Leave a space and move the constant over to the other side. All right, do that. Okay, now x squared minus 6x plus, okay, we're going to fill in that spot in a second. Y squared plus 10y plus this spot here equals 2 plus, anything you put on the left, you got to match it on the right. Just so you good old fashioned balance, you know, whatever's on the left side, you got to keep it on the right side. All right, half of -6. -6 divided by 2 is -3. Square that. That's 9. That will go right here, and then put a 9 over here. Half of 10 is 2. That's 5. Square it. Put 25 here. Put 25 here. Now factor there. So what's x squared minus 6x plus 9? This is the whole reason we do this, is so we can write it as a quantity squared. It's going to be x minus 3 squared plus y plus 5 squared. And then what do we get over there? 36? All right, now it's pretty straight, easy. What's your center? What's your radius? Center is 3 - 5. And what do we get for radius is 6, square root of that. All right. So if it's not in the nice form, we got to make it look like the nice form. All right, same thing here. 2x squared plus 2y squared plus 8y minus 2 equals 0. All right, there's one little difference between this one and the last one. Well, there's a couple differences. You got a coefficient in front of x squared and y squared. What else is maybe a difference? What's missing? There's no x term. Actually, that's better. All right, first thing you got to do though is you cannot have a constant. You cannot complete the square when there's a constant in front, which caused some issues on the test. I mean, you forgot to divide by that coefficient. So we got to get rid of the 2. First thing we got to do is get rid of that. And so we divide everything by 2. Minus 1 equals 0. All right, there's no x term. You do not have to complete the square. That's actually okay. That actually makes it easier. We're going to have to complete the square with the y. Move the 1 to the other side. So you're going to have x squared plus y squared plus 4y. Leave a space. Move 1. So we got to fill in that. Well, what's half of 4? 2 squared is 4. So that's going to go here. That's going to go here. All right. Just leave the x squared. That's perfectly fine. This becomes y plus 2 squared equals 5. Well, think of x squared as simply x minus 0 squared. So what's the x coefficient of your circle, or the x coefficient of the center? It will just be 0. And so it's going to be 0 comma what? -2? Here's my center. 0, -2, and my radius is square root of 5. Okay, square root of 5. All right, so even though there's no x term, can't complete the square, that's actually better. Okay, we just show you don't need to worry about that. All right, take a look at this last one. I want to see what you come up with on your own. Find the center radius form of the circle with center 4, 2, passing through the point 0, -3. Now, I know you don't have the picture, but it gives you a good visual up here if you want to sketch it out. All right, if you think you got it, let me take a peek. And just so you know what you're shooting for in terms of your answer, I mean, it should look something like, x minus 5 squared plus y plus 2 squared equals 18, something like that. Final answer should look like that. Should have a number here, here, and here. Okay? Okay, but now just you got everything, just make sure you put it in that equation. Just write it in a formal equation.
Okay.
Okay, so,
Take it all the way down.
well, you needed to get that. And then just then end up go back and write like that. Okay, so. Okay, it should, when you're done, it's gonna be, here's the final answer. It's gonna be x minus 4 squared plus y minus 2 squared equals 41. Okay, that's the answer. Just sometimes how to write it push. Now, you know the center, so you should be able to at least come up with this. But we don't know the radius at this point. So it's got to be in these first two, got to be like that. Well, we got to find the radius. Well, I know the 2 points. I know the center right here. I know the point 0, -3. That's what it means by passing through that point. So you draw that circle, it's going to hit that point. Well, there's your radius. All I got to do is find the distance between those 2 points. Now, some people plug it into here. You could also just use the distance formula. Do 0 minus 4 squared plus -3 minus 2 squared. And that's -4 squared is 16. That's going to be a positive 25. Square root of 41. Well, square root of 41, you want to square it. Okay, so that's where we get that. So make sure you have that as your final answer. What do we say? X minus 4 squared plus y minus 2 squared equals 41. All right, yesterday you talked about X and Y intercepts, or you learned about, today we talked about symmetry and dealing with circles. Okay, dealing with equations of circles. All right, page 196.